Assalamualaikum and very good morning to everyone. My name is Muhammad Aminuddin from Group 7. So today I will present about two types of milling process. So in my hand, this is the workpiece and this is the cutter. And this is the milling machine. But unfortunately, the instructor are not here, so we cannot operate this machine without the supervision of the instructor. So don't worry, I will relatively show you how the process works. So I will explain about two types of milling process, which is peripheral milling and the other one is face milling. So peripheral milling is the cutter, this one is parallel to the surface of a piece that being machined. That means it will look like this. So the cutter will move from the side view. The cutter will move like this. Okay, next is face milling. Face milling is the cutter will be parallel to the surface of the workpiece that being milled. So the cutter will spin like this, like the normal milling does. And then the other type of face milling is offset from the surface, which is the cutter will not cut all the workpiece surface, but it will only cut a portion of the workpiece. For example, like this, it will only cut this side only. Okay, thank you.
Okay, now we look at drilling. So there are two types of holes in drilling. First is through hole, which is drill exit opposite side of work, and two blind hole, does not exit work opposite. So this is the picture of through hole drilling and blind hole drilling. And then next, there are three types of drilling. The first one is reaming, the second one is stepping, the third one is counterboring. I'll show them in the next video. Okay, first we will look at reaming. This is the reaming tool or reamer. When we will drill a hole, it's pretty much a roughing operation. Reaming is designed to take off a little bit of the material, but it cleans the hole out. The second one is stepping. This is step. Its function is to put thread inside a hole. First we chamfer the hole a little bit to make it easy to enter, and then we put the tab a little slowly so it won't incline in direction. So as we can see, we move the tab back and forth to ensure the chip, to enable the chip to get out easily. And then we can continue the thread until the end. As we can see, we reverse back the tab so the chip will follow the thread to go back out. Usually the tab hole is longer than the fastener. It is enabled to the fastener to fit in the hole completely. Then counter boring. It is used to make hole for socket, cap, screw. First we need to drill the hole a little bit at first, and then we continue to the depth desired. So that is the socket head cap screw. That's all from me.
Okay, good morning. I'm Kong Yen Teng from Group 7. So now I'm going to explain about the cutting tool technology. So we know that there is 4 cutting tool technology. The first one is is the tool line. The second one is the tool geometry, and the third one is the tool material, and then the fourth one is the cutting fluids. So next I'm going to explain about the three modes of tool failure. So we know that the first one of the tool failure is caused by the fracture failure, and then the second one is the temperature failure, and then the third one is the gradual wear. So in the gradual wear there is crater wear and the flank wear. Okay, so on my hand there is two cutting tool has already failure. So for the first one, we can see that the failure is caused by the crater failure. The crater failure is measuring on the surface, and then there is also flank failure. So flank failure is measured on the side of the cutting tool. So for the second cutting tool, it is caused by the fracture failure. So you can see that the cutting tool is already fractured. Okay, now I'm going to explain about the Taylor-Life equation. So the Taylor-Life equation is given by Vtn equal to C. So the V is equal to cutting speed, and then T is the tool life, N is the slope of the plot, and C is the intercept on the speed axis at 1 minute tool life. From the example, we know that V1 is equal to 350. And the T1 is equal to 45 minutes. The V2 is equal to 250 meter per minute. And T2 is equal to 75 minutes. So from there we can substitute into the Taylor equation, which is Vtn equal to C. So we will get equation 1 and equation 2. So we divide the equation. We solve this equation by using log. So we will get the value of n is equal to 0.65868. Substitute into the equation, we will get the C is equal to 4295.48. And then the question wants us to find the cutting tool speed, which given the tool life is equal to 55 minutes. So we want to find V3 is equal to what? So we're using the Taylor equation. We substitute all the value. We will get V is equal to 306.67 meter per minute. So that's all for example.